Hi, everyone. This is Hossein from EJ Academy. We are here. I'm here with Amir. How are you, Amir?
Good. How are you?
Good, good. So we are going to go over another calculus problem. This time, the objective of this video is finding derivative of an inverse function. So, Amir, I have a problem for you to solve.
Yes, yeah,
Okay, let me read the problem for you.
sure.
So assume I have a function f of x, which is equal to 6 times log of 2x, but base of 2. So find the derivative of inverse of this function at 12, x equal 12.
Sure, yeah. That's an interesting problem. I believe we had a relation which we use for inverse function, derivative of inverse function. First, I'm going to obtain that relation for our viewers. If we assume that y is equal to f inverse of x, then we can say that, okay, f of y is equal to x. And you know, function f should be a one-to-one differentiable function, and also f inverse should also be differentiable function.
Okay.
In this
So one-to-one function means that, you know, for every x, you have only one value for the y.
Correct. Yeah, that's
and
correct.
then differentiable function means that the function is continuous,
Yeah.
and also the derivative of the left side and the right side are the same.
Yeah, at a specific point, the derivative
At
of
any
left
point,
yeah,
right?
yeah, correct.
Okay.
So with that assumption, we have this one. So I'm gonna take a derivative of both sides with respect to x. Derivative of the right side with respect to x is 1. It's simple. I will write it very soon, but let me look at the derivative of the left side, this one. So I'm
the
gonna
trick
use,
is it's not in terms of x, it's in terms of y,
yes, the
which
trick, yeah,
itself in terms of it is in terms of x.
correct, yeah. Y is in terms of x.
Yeah.
So I'm gonna use chain rule.
In
this case, we have, okay, df over dx is equal to df over dy with respect to y.
If the viewers wanted to refresh their mind about the chain rule, we have a video about it. I put up the link here.
Yeah, absolutely.
I think probably at the top, you're going to find it.
Yes, yeah. So it's going to be, okay, I'm going to use f prime y for the first term. Here f prime means in terms of y, and dy over dx as y prime. So on the right again, I write this one, that I use this notation. Y prime, that's the short form.
Fair enough.
Yeah. So with this one, if we actually take the derivative of both sides, we get f y times y prime is equal to 1.
So 1 is the derivative of x with respect to x.
That's correct. You know that dx over dx is 1.
Yeah, thank you.
And from here, I get y prime
right, is equal
to 1 over f prime of y. And here we have this definition.
Right. So you're going to substitute that.
Substitute that. So instead of y, I put f inverse of x.
prime.
Yeah, let me just write like this.
F inverse prime of x
is equal to 1 divided by f prime of y,
which
which
is
is
f
again f inverse
inverse
of x. So
That's awesome.
yeah, we have this relationship here.
Mhm. This is the relationship between the derivative of the function and derivative of the inverse of that function.
That's correct. So, okay, here you want me to obtain this guy, yeah?
Mhm.
So I'm
Derivative
gonna write
of inverse of f at 12.
Yeah. So using the relation that I just obtained,
Mhm.
x of 12 is going to be 1 divided by f prime of am I right?
Yes, that's correct.
Yeah. So instead of x here, I replace 12.
Correct.
Okay, here I don't know the value of inverse of f at 12.
Correct.
So
So you need
I
to find
say,
that.
yeah. So if I call it just like a value like x or
Mhm.
yeah,
Yeah, x is unknown.
unknown, yeah, because I that's unknown here, as you can see.
Right.
Then based on the definition of the inverse of a function, it's going to be 12 is equal to f of x.
Correct.
Correct?
Right. So
So
x for f, it's equal to y for, I'm sorry, y relationship between the x and y changes.
yeah,
When you switch from f to
yeah.
inverse of f.
Right now
Correct.
it is like y value, y
Mhm.
intercept. So
Right.
that's because of the properties of the inverse of a function.
Correct.
So, okay, this is what we are looking now.
Mhm.
And as we can see here, we have f of x.
Mhm.
So I think that's straightforward. So
You're gonna solve an equation here.
yes, I'm gonna solve an equation. F of x is 6 times log of 2 times x, the basis of 2 equals 12.
Mhm.
So I'm gonna divide both sides by 6. So it's going to be log of 2x, 2 equals to 2.
Correct.
And based on a definition of,
Log.
logarithm, yeah,
Yeah.
log of a on base of b equals to c. So a is b to the power of c.
Yes. Yes, that's correct.
So based on that, I can obtain 2x is equal to 2 to the power of 2.
Mm-hmm.
2 to the power of 2.
Yeah.
So it is 4, then x is equal to 2.
That's correct.
Okay, so the unknown here is 2, correct?
Right.
So, okay.
So you can put that back into the
Yeah, if I call this
equation.
1, if I call this 2, based on 1 and 2, I get
F inverse, derivative of f inverse at 12 is equal to
1 over f prime of 2.
That's correct.
So this is the 2 that we just obtained here.
Right.
Okay. Now I need to know the derivative of f. So this is the function that I have.
Mm-hmm. You need to find the derivative of that function.
Correct.
And evaluate it at 2.
Correct. So on the side, I'm going to write when you have y is equal to log of u, which is a function in terms of x, with the base of b,
Mm-hmm.
y
B
prime,
is constant.
Yes, b is constant. Y prime is u prime divided by u ln of b, natural logarithm.
Right.
So
U is a
that's
function of x, so
yeah.
u prime is a derivative with respect to x.
Yeah, it's a function of x, correct.
Right.
So given that, I'm going to use this relation to obtain the f prime of x.
Mm-hmm.
So f of x was 6 log of 2 of x on 2. Then f prime of x is equal to, okay, here is u. So it's going to be, okay, we have 6 u prime. So 2x, the derivative of 2x in terms of x is 2.
Is 2, right.
Divided by u, which is 2x ln of 2.
Yeah.
So these are gonna get canceled,
right.
and then f prime of x is equal to 6 over
ln of
x.
x ln of 2.
Yeah, ln of 2. So at point 2, f prime of 2 is equal to 6, 2 ln of 2. So it's 3 ln of 2.
Yeah, you
right?
cancel. Yeah, you just cancel 2 on the denominator and 6 on the numerator.
Yes, correct.
Yeah.
And okay, if I call this one 3 and this one 4, then I go to the next page. F inverse of
Derivative of f inverse of
yes,
f inverse at 12 is equal to
1 over, okay, here, which is this guy.
Yeah, 4 that you obtain.
3 over ln of 2. So it's going to be ln of 2 divided by 3.
Okay,
and
that's
yeah,
awesome.
that's the actually answer for the question.
Okay, thank you, Amir. I appreciate it. That's really awesome.
Sure.
Yeah. Okay. So for the viewers, that is all for today. I hope you learn something from this video, and I appreciate if this video was helpful for you, considering subscribing to our channel, and also hit the notification bell so you get notified regarding future video that we're going to upload to our channel. Till next video, bye everyone.
Bye. Thank you.